Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel and it also helps us reach others in need of assistance with these topics. So in today's video, we are going to be going over statics, equilibrium of rigid bodies, and we're going to be utilizing reactions here to solve the problem. And this will be our 19th part in this particular series. So what we have going on is that we have this pedal shown here on the left, and we have to determine the maximum tension in the cable AB right here if the maximum allowed magnitude of the reaction at C is 650 pounds. So what we're looking for is this maximum tension force, which I'm just going to call T. We have this unknown P force here at point D, and we are told that the maximum reaction is 650 pounds at C. So that reaction, the way it is written, it doesn't say reactions or reactions in the X or Y. It's saying the overall reaction at C is 650 pounds. So what this means is that that reaction is at some angle 650 pounds. It is not saying that we know what our vertical reaction or our horizontal reaction, C sub X and C sub Y, are at point C. But C sub R will be equal to, if you remember from components and resultants, it will be the square root of C sub X squared plus C sub Y squared. Well, what are C sub X and C sub Y? Well, if we sum forces in the X and Y direction, since we're going to have equilibrium here, well, we would have our tension force subtracting, or our negative tension force plus our C sub X would be equal to 0. So what that means is that C sub X is actually equal to the tension force in the cable. And if we repeat the process for the Y direction by summing forces, everything being equal to 0 in the vertical direction, we would have C sub Y minus P is equal to 0. Thus, C sub Y is equal to that unknown P force. So let's go ahead and let's plug in our tension and our unknown P force into our CR equation, and we end up with this. So we would have 650 pounds is equal to the square root of T squared plus P squared. Well, how does that really help us? Well, what we can do is that we can relate our tension force to this unknown P force. And the way we're going to do that is that we're going to sum moments about point C. So when we sum moments about point C, C sub X and C sub Y and the 650 all drop out because they go right through point C. So then we will be left with a relationship that shows how T and P are related. So if we sum moments here about point C, everything equal to 0, well, we would have our T times its perpendicular distance to C, which would be the vertical of 5 inches. And then we would have our P force times its horizontal distance over to C, which would be 12 inches. And that must be equal to 0. So what this means is that if we write this in terms of P equals something of T, which would be 5/12 of T, we can take this and plug it into this relationship over here, and then our only term remaining is our tension force, which is what we're looking for. So that's how you would use equilibrium in your reactions in order to get this solution workable where you have one unknown, which is your applied tension force. The only hiccup here is that they didn't give you the reactions in the X and Y direction, they gave you the overall reaction, the combination of the resultant there. All right, so at this point, it just becomes some algebra to work through here. So we would have T squared plus 5/12 of T squared. So let's get rid of the square root and square each side. So this would just be 650 squared is equal to T squared. And then if we square through here, we would have 5/12, which becomes 25 over 144 T squared. Combine the T squareds together, and we end up with 650 squared is equal to, well, 25 over 144 plus 1 gives us 1.1736 T squared. So let's rearrange and solve for T, our tension force, which is going to be 650 squared divided by 1.1736. And then you square root that because of the square of the T, and we end up with 600 pounds of tension force in that cable. And that's how you would solve that particular problem, utilizing the relationship of equilibrium of rigid bodies, utilizing the reaction relationships, and pulling into and solving down into one unknown variable. So I hope this video was helpful. And if you want to see more problem solvers variety, please check out the other videos on our channel. Also, if you haven't done already, please like this video, leave a positive comment below, and subscribe to the channel. Thank you for watching, and I hope you have a fantastic day.